We're looking for the dark matter, the missing energy in the universe. Everybody has a name for it. Tachyon, monopole by Maxwell to symmetrize his electrical equation. Ether or inertia ether. You can even call it spirit or prana or chi. But what I was able to discover was that this missing energy travels in a straight line along the z-axis. And it travels omnidirectionally. And it causes everything to curve and warp. That's why the universe, that's why every shape ultimately takes the shape of a donut.
Donuts are much like life. They're round on the outside and empty in the middle.
We got this time, got the pulse width. It is pulsing a coil from a GMC van. It's actually pulsing the relay. It seems to work a little better if I pulse the relay and then give that the coil the ground. So basically, instead of sending that spark to the plug, I'm sending it through the Rodin, comes back out the Rodin, then jumps into the plug, and then jumps out the back to go to ground. Pretty cool. This puts about, I believe it takes about, what, 10,000 volts to jump an arc. So we're putting some pretty high voltage to this coil. That meter is on the AC scale. The two leads are in mid-air, not really doing anything. We can make sure they're not touching wood or anything. So they're kind of suspended in the air. Now, I'm just going to turn this on, and the relay is what you're hearing clicking, but it's picking up a field, and those are about a foot away. So 14 volts AC outside of this. Now that's pretty darn cool. Okay, there's my rod. See that? And sparks are jumping out of the coil, I do believe. Otherwise, I'd imagine I'd have melted the insulation by now on the wire. And it seems to be more predominant towards that inside edge. It doesn't really want to do it anywhere out here. And for whatever reason, I'm not grounded. I'm not getting electrocuted. Alright, it's a fluke clamp meter set to amps. And we're getting a reading of about 50, a little more, a little less. It goes up and down. Seen it get up to 52, 53. Sits right around 50. So it's a 60 watt light bulb that's hooked into it. Very nice. So 60 watts is a half an amp at 120 volts. Which means for every amp that I put in there, I'm going to get 100 amps out of the center of a magnetic field. What we have here is an alternator, custom-made magnet. It's an N50 Neo, 2 inches by 1 inch. I wanted to show you guys the concept of magnetic gearing. A 1 inch magnet, Neo M42. I'm going to hold it right here. This is how magnetic gearing works. The idea is if we can get the coil to push the small magnet, we can get the large magnet to rotate the alternator. Like a small gear with a lot of RPMs, we'll move a large gear to add torque. But it's pretty much what we got going on here. Here we go.
So, it's moving real fast now. It's got a lot of torque. There's no way I can stop that with my finger like this. Not a chance. So we got enough torque. And with Jack's circuit, Mr. Jack Scholes, you can check him on Ace Club's Motor Gen. And that supplies the circuit and another coil that I built and sent to him, tested out. You can get these things to run about 22,000 RPMs. Figure with the torque and the RPMs, we can make this thing move real fast. Just like that.
Rotate it here so you can see that red mark. See, it starts to vibrate. It won't self-start, this won't spin. I have to kind of give it a little push. Once I get it up to speed, it spins quite nicely. And it'll spin anywhere in this field here. Really, what's spinning this is the rotating magnet in the center of the coil. And there's actually quite a bit of torque on the shaft down here. It's really kind of hard to stop it with my fingers. But if I do stop it, you can hear it. You can hear that. And when I do get this thing going, just so you'll know that that's rotating instead of vibrating. If I stop this magnet with my fingers, so that one comes to a stop. Another video posted real quick. One of the first comments was, will this thing levitate in the air by itself? So I put some put some tape on the copper windings to protect them. We got my needle ball here. The coil is energized. Put it in there and you'll see it takes off. Chase it around the floor. You have to hold it because it's got a lot of energy, a lot of magnetic energy in here. Alright, you can see it. I'm going to pick it up off the table. You can see it just holding itself in midair right in the middle of the coil. And it's spinning rapidly, pretty much the same as you saw in the Rodin Coil Fix 5 video. Spinning just as fast. You don't really hear it because it's basically floating in midair. See if I can show you guys this. I got to keep it straight. There it is. What you're looking at right here is a flattened out, formless Rodin coil. It actually came off of one of the yellow toll roads. I built a standard 36 Rodin coil with 9 winds instead of 18. So this one was pretty much the same as this, but what I did was I took my X-Acto knife and cut out the yellow form, and then I decided just to mash the windings flat and see what this thing would look like. Okay, so you can kind of get an idea. It's used to be a Rodin coil, or somewhat kind of is. Here's my needle ball. The coil is already energized. Let's see, I'm gonna get my thing hooked up here. I'll tell you what the volts are. There we go. So right now we've got 2.38, 2.39 volts, and on my ammeter here we got 1.53 amps. All right, so I'm gonna put my needle ball in here, and see it, get it to start spinning. It levitates in there quite nicely. I can move it around. You know, it likes to dangle a little bit.
Y acabo de terminar hace unos minutos. Y bien, vamos a hacerlo. Arrancar el motor. Sí, es algo increíble. Todo lo produce el centro de la estrella. Hacerle un test de velocidad. Esto es lo que está generando 12.648 revoluciones. Y bien, vamos a descargar el capacitor.
If I was to show you the frequency counter at the same time, and we can get it rocking quite a bit, and then if we turn the DC offset slightly toward the middle now, and then turn up the frequency, It's about 16. We're getting that spinning nicely.
Folks, this is a new test we're doing here. This is a new coil I just finished winding. It's a tertiary coil. It's basically the standard Rodin coil with about a total of about 48 to 50 windings with the two bifilar windings combined. And that's wrapped around a ferrite core, and then that's wrapped with 3 windings of 16 gauge speaker wire. What we're doing here is we're looking at the on voltage for a basic red LED. There's a little red LED in this little mounting boss here. This is a 1-foot tube. On the other end is a detector for a flux meter or light meter. Light meter is set to foot candles on the low setting. And here we have a Craftsman multimeter set to the milliamp, 2 milliamp rating. We're in the milliamp rating, so this is our amp gauge or function generator, and it's set at frequency is 27.8 kilohertz, and the voltage is 3.16 volts. And first we're going to look at the on voltage here for the LED, so it's about 3.16, and I'm turning it up now. I'm just watching the light meter on escape. Now it comes on. So it comes on, the on voltage is 3.27 volts for this LED. And as a baseline, I'm just using 0.05 foot candles as my baseline test for the total luminance on the LED. So I'm tuning up the voltage here to get that 0.5, and we're rolling up on the 4, and as soon as it rolls to the 5, we'll have a look at the voltage. Okay, we roll to 5, and we're looking at 5.31 volts at 0.997 milliamps. So, we're looking at about, almost 1 milliamp at 5.3 volts. So we're looking at least, 5.3 milliwatts to drive this thing to that point. And you can see the connections here we have. It's just real simple. The 2 leads from the function generator just going through the amp gauge and into the light. So now what we're going to do is take these off. We haven't changed any of the settings here. We're still pulling the same amount, same voltage, same foot candles. And we'll take that off, pulling it off here, and then we're going to hook these up to the secondary on the coil. And automatically have higher voltage because of the winding ratio. It's about a 13 to 1. And then we're going to go ahead and hook up our inputs, and that'll be on just one side of this. I don't use both of them. And I have a little jumper wire here I got to put on that will help to understand this stuff a little better and transmit this. So it's just a jumper wire put on here so I can clip onto here. So now we've clipped onto there, and now we're putting out 20 0.20 foot candles, so 4 times as much light is being put out. Now we've went past our scale here, right? It's over limit. Voltage is the same, frequency is the same. So we'll go back to voltage now. We're going to reduce this voltage down, right, until we get to 0.05. So we're going down here, we're down here, we went down too low. So we went past, we're down to 0.95 volts. We're going to look at our on voltage again on this setup. So as soon as we get the readout there, we'll stop and look at the voltage. Okay, 1.70 volts, so much lower than I think the 3.5 something that we had for the on voltage without the coil. That makes sense, we have a higher voltage, but what we're going to see here is the amperage is not much higher. So now we're going to bring this up to the voltage up high enough to bring this to 0.05, and we're going to change this on the 200 milliamp scale, and we find that it's just over, it's just 1 milliamp as well, 1.0. So just slightly higher on the amperage, but the voltage, oh, excuse me, we can go down a little more. It's at 9. A little more down. We're down to 5 here. Excuse me, 4. Turn it up a little more. Too far. There. Okay. So that's only 1.98 volts, about 2 volts compared to the other much higher voltage, and that we're at 0.2 milliamps. It actually dropped. So you can see there's a great efficiency gain by using the Rodin coil to drive this.
What this is, when made properly, is called a reactionless drive. It's an engineer's dream shop come true, because it's not supposed to be affected by any weight, any load that it's pulling. Okay, well, there's no such thing as a permanent monopole magnet, so what you're seeing is not real and is not happening. And this does not exist. Nothing. This is the Rodin coil hooked up. I'm putting the load on it. There is no south pole on the Rodin coil. There's south that's showing on that magnet, so there's no dispute and it can show south. It works. I'm going to start off with showing that it does not do a south. I'm pushing it, nothing. Go to north, look at that. See, there it is. Okay, I'm keeping my finger continuously down. I'm not pressing this button, just keeping it down. Okay, now I'm going to the south, nothing. Okay, what's the significance of this? Is it making a Wheatstone bridge? Is it having weight differential, gravity, asymmetry? Does it weigh more on one side of the coil than it does on the other? If you turn upside down, would you have a different weight on a scale? I designed this to be a nozzle. I call it the flux thruster atom pulser. I said that you could use this hole to go through space.
The magnets that you see here are arrayed are just for some other stuff I've been doing, but I wanted to show you this for demonstration purposes. All right, first of all, this is just a steel, carbon steel Allen wrench, right? Okay, and if I push this button, you guys can see this here. See how it turns north and south, right? Depending on which pole the magnet is on. Okay, so if I put it up this way, I don't get anything, right? It's not magnetized. Right? Can you guys see that? Okay. All right. So now what I've got here is I've got a light bulb for a load. And I've got my electronics in this box, and I'm pulsing the coil. I'm going to put this back over there so you guys don't get blinded with the camera. Alright, so as we showed, right, I have nothing on here, and this is a negative pole detector, okay? So I'm going to stick this carbon steel in here, and I'll immediately get north pulsing. Alright, closer we're going to get. Alright, so I'm going to leave that in there for just a second. Doesn't really matter so much. And I'm just going to turn this on and off a couple of times. Give it some pulsing. Alright, should be good. Alright, let's pull it out and see what happens. It's off. Yeah, so I got the coil is off. And I just magnetize this barely. If I move this thing around, I have no south energy. If you hear me hitting the button. No south. Still working. Alright? No south. Unless you get all the way to the top.